9.1 Introduction. Probability is an analysis of the likelihood that an event will happen. We often encounter the concept of probability, which is about chance and opportunity in our daily life and conversation. For example, expressions such as "it will probably rain in the afternoon" or "my chance of scoring an A in statistics is high," or "I am certain to get a job immediately after my graduation," based on the concept of probability. So there's 3 different conceptual approaches used to determine probability values. First, the classic approach, where the probability is computed by finding the ratio of the number of possible outcomes included in event A to the number of possible outcomes included in the sample space. Next, the relative frequency approach, where the probability is the proportion of the frequency of a favorable outcome which happen in a number of observations or experiments. Next, the subjective approach, where the probability is the degree of belief by an individual that an event will happen based on the evidence and the information provided. The mathematical theory of probability was first introduced by French mathematicians Blaise Pascal and Pierre Fermat when they were trying to solve some gambling problem involving dice. The theory of probability has been widely applied in various fields of study such as medicine, engineering, meteorology, earthquake prediction, agriculture, marketing, and finance. In this chapter, we will introduce methods for counting which included permutation and combination, followed by the rules of probability, tree diagram, and Bayes' theorem.
Permutations. A permutation is any particular arrangement of r subjects which are selected from a set of n distinct objects, where r smaller than n. There are 2 types of permutation. A. Where repetition is allowed. When we have n things to choose from, we have n choice each time. Therefore, when choosing r of that, the number of permutation is n multiply r times equal n power r. B. Where repetition is not allowed. In this case, we have to reduce the number of available choice each time. The formula to determine the number of permutation is power n p power r equal n per n minus r. Example, a doctor has 3 examinations rooms. There are 6 patients in the waiting room. In how many different ways can patient be assigned to the examination room?
A combination is the number of ways in selecting R objects from a distinct object where the order is not important. For example, we have a set of 3 letters A, B, and C. We might ask how many ways we can select 2 letters from that set. Each possible selection would be an example of a combination. The complete list of possible selections would be AB, AC, and BC.